morning, afternoon, everyone. We're going to finish off 8.5 today. I've already done this lesson once with my Monday class and it didn't go too well because the software was acting up. So hopefully it'll behave, because I went in and tried it again and it was fine, so go figure. So I guess computer software have bad days like human beings do. So we're going to look at testing for differences in means, right? Hypothesis testing, where we're looking at two populations and we're comparing the means in some way. And I'm going to break these questions into two distinct kinds of questions. There's the ones where you're told everything, right? You're told the mean of the samples and the standard deviations and everything. And that's going to be question 11. Question 12 and 13 you won't, and 14 and 15 you will. So they're essentially 5 questions. We get these 5 guys done, we've pretty much covered everything we need. And that will be 8.5 finished. Then you can have and hopefully enjoy your Thanksgiving. And when I see you next week, which is our last week really, apart from my Monday, we'll get chapter 9 done. But there's only 2 sections in chapter 9, so we should get that. And we also have Monday. So let's give you a background to it. You're going to have 2 populations. And we're going to be comparing them in some way. So I'm going to have a little story. I'll call this population 1. This is going to be population 2. And we're going to have as our variable the average weight. So we were interested in seeing, is there any difference between the average weight of a Scottish person and the average weight of an American? And the question that we were interested in testing would go something like this. Is there enough evidence to show that Scots people are lighter on average than Americans? So to try and answer this question, you do some samples, some nice random samples. So we randomly got 200 Scotsmen and women, and we found that their average weight was 195, and that the standard deviation of this was 15. And we did the same with Scott. And we did the same with the Americans, and we got a sample of, say, 300. And that it was 201 pounds. And it was 25. Now, the only other thing that we need to be told in these questions, so this is me doing essentially questions that are going to be like situation 1. So that's going to be questions like 11, 14, and 15. The only other thing that's missing is the significance level. And let's say the significance level is 0.01. So how do we take all of that information and create a hypothesis test? Well, we're going to start by setting up what the 2 hypotheses are. Now, when you do means, right, they're called mu1 and mu2. Remember, the mu means the mean of the population. So the null hypothesis will always be that the 2 populations have the same mean. And the alternate hypothesis will depend on what's being asked to be proven here. So you're being asked to prove that the Scots are lighter than the Americans. So µ1 is the average Scotsman, and he's less than the average weight of an American. And that would be an example of the hypothesis test that matches this story. Now, this can be written in a second format, and the reason we need to see the second way to write that is just because the software that's going to do all the work writes it down slightly differently. Equivalent to that is to say that the difference is 0. Would you agree? µ1 taken µ2 is equal to 0. It's the same thing as saying these are equal. And this one is equivalent to that. And the reason we need that way around is that in salt, you're going to have a place to put 0. And right next to it, at least in this question here, you're going to the choice less than. So when you go and you use the software, you have to have a way of describing this, and we describe it in this strange way that 0, but I'm less than you, which is essentially saying that. Now we've got all the information. All we need now is somebody else, meaning some software, to get the t-score and to find the p-value. Now, I did this with my Monday class, but I'm not going to do it with you this time at all. We're basically going to let the software do this. It's far too time consuming otherwise. I mean, I couldn't really even give you a question like that in the final, because if I did, 20 minutes of your 2 hours would be used up on just one question, and that doesn't seem a good way to test. Right, so let's go over, and I've already set up. Hopefully you are looking at a big button that says salt. I need a nod or a thumbs up because I can't tell what you can see. I get a nod, we are good. And that's going to lead to here. Now, in this particular situation, we want to hit this button here called inferential statistics. And I'm just going to make this screen a little bit larger. Hopefully it'll help you see what's going on. Okay. So far, so good. Now, everything that we've already collected, the population, the sample size, the mean, and all that gets fitted in here. So first thing you're going to pick is a 2-sample T. This is a 2-sample thing, right? There's 2 populations, 2 samples, right? And the sample mean for the first group, which is Scottish people, was 195. The standard deviation for the Scottish people was 15, and that the sample size for the Scottish people were 200. If we go on to the second one here, the American data, the sample mean was 201. The standard deviation was 25, and there was a sample size of 300. And the hypothesis that we were testing was that it was less than 0. Remember, I wrote that down a few moments ago. Less than 0. And that's how you set it up, right? 0, less than. And then you hit generate results. And what you can see here is all the stuff you need to know. This fella here, for instance, is your t-score. In this particular question, it's negative 3.3497 and lots of other things. And the p-value is this fella, which is in this case 0.000435. Are we comfortable about how you put the data into it to pick out the t-score and the p-value? So I'm now going to return to our screen where I've written all that information down. and we can look at how you finish the question off. Read the question, because it might say to 2 decimal places, to 3 decimal places, and that could be important. So let's just pretend that they wanted this question to 2 decimal places. Then that's what you would write in. You know how fussy WebAssign is? If you write 3 decimal places when it should be 2, it's going to ding you and say you're wrong. And when it does the p-value, well, it depends on the question, but I'm pretty sure, yeah, that when you do a typical question, they don't actually have a box where you type in the p-value. What they will have instead is a number of choices. And you will then put your guy into the choice. So you might have that, and then the next one. Takes me a long time to write this, but I'm only going to do it once. So they'll give you a choice. And depending on what this number is, you will only pick one of these. So in this particular case, would you agree it's that last one? So you would mark that in your homework. Okay. That makes sense? Now, can you pretend that this wasn't that number? Can you pretend it was 0.11, right? 0.11. If it was 0.11, wouldn't I pick that second dot? Right, a p-value of 0.11, I'd pick that one. If it was a 0.06, right, imagine I got a 0.06, then I would be picking the third one, and so on. So you'll write down the t-score will actually have a box where you'll put it in. They just call it the test statistic. That's just the name they're giving to it, but it's your t-score. And the p-value you'll just have to choose from the list. Now, the third and final stage is that we need to test our hypothesis. And it's basically the same test that you do every situation. Is your p-value, in our case, 0.3 more zeros and a 435, is that guy less than the significance level? And the answer is yes. And when the answer is yes, there are 2 standard answers that you pick, because you get like 4 choices, but you pick one. And then these are called what you got when you conclude the test. And then there's 4 other answers that you get when it, and they call it interpret the results. When the answer is yes, you will always pick the following sentence. At the alpha equals, in this case, 0.01, we reject the null hypothesis and then it finishes with, and we conclude the data are statistically significant. I should put that in red, I guess. And that's what you do if the answer is a yes. And it's basically the same 4 choices. They randomly, sometimes it's the first choice, it's, they shuffle them up, but that's the one that you would pick here. Now, when it comes to interpret results, you're basically going to write down this sentence or equivalent, reject the null hypothesis, and the rest of it is like this. There is sufficient evidence to show, prove, whatever the word they want, that, what did we have? In this case, we got significant evidence that Scots are lighter than Americans. And you always choose the sentence that looks like that when there's a yes. So that's the answer for yes, and that's the answer for yes in those two. And they finish off with A2 pretty much every time. So start to finish, this is your template for doing questions 11, 14, and 15, right? This is how you're going to go about it. Any questions so far? Okay, then let's show you one. This is question 11. Oh, we've got something in chats or something I should know. Okay, I got you. So here goes. So we have a whole load of information here. I'm going to keep it on the screen for a little while, although I'll be writing down some of it so that when I return to the white paper, you'll be able to see where it's all coming from. But right now, what do we have? A random sample of 49 measurements from one population. So they're not even giving it a name except one population. There are 49 people in that sample. And the mean from that sample was 14. And the standard deviation from that sample was 5. And then I read a little bit further on, there was a second population and 64 measurements from that one. And the sample mean was 17. And the standard deviation was 6. And the significance level in this case is 0.01. So I'm going to just go back and show you what I've just done. Right, are you comfortable how I just read what they told me and put it into this format, right? The X1, S1s, all the good stuff. Right, now, what distribution you're going to use, you're always going to answer this one. Right. Now, we have some hypotheses to set up. Well, we need to know what they want us to do. Test the claim that the population means are different, right? It's not one is bigger than the other or one is less, although they have to be either. It's just, are they different? Can you see this is your H, not HA? Equal, different, not equal. That's called a two-tailed test. Now I'm going to use SALT now. And the reason I'm going to do that is because I need to find my p-value and my t-value, right? So I'm going to click on this fella. I'm going to go to sample. The first one had a mean of 14. it had a standard deviation of 5. And in this sample, there were 49 things. And in sample 2, the mean was 17. The standard deviation was 6. And the sample size was 64. And we are testing that the difference, which is always 0, not equal to. Generate results. And we have a p-value and a test statistic. The test statistic in this case is negative 2.896. And the p-value is a 0.0045. The difference between the two, I didn't actually write that down, but it's negative 3. Can you see the 2.897, because that's what it rounds off to, where that came from? And we had a p-value that's in this range here. It was 0.0045, so it belongs there. Are we good so far? Right, so what do we know? Well, we know that's going to be less than the significance level. Right, 0.0045 is going to be less than alpha. So this is a yes. And when it's a yes, there's the sentence for yes again, same one I did last time. And there's your sentence for F. And the question is over. Anybody unsure about anything I just did there, or do you feel comfortable? Okay. Move on. Skip those two. We're doing them last. So in this case, they are looking at a peer tutoring program to help children to read. In this case, there are two groups. One is in this experiment, they were divided into two. And the first group I'm going to call the experimental group. And in that group, there were 30. The mean score of the first group was 344.5. The standard deviation for that first group was 49.9. In the second group, which should be just a control group, let's see what happened to these. The children were randomly divided into two groups. The experimental group received peer tutoring along with normal instruction, and the control group just got normal instruction. They didn't get this thing called peer tutoring. So we're going to essentially find out if it does any good. In the second group then, there was also 30. The mean in that group was 353. And the standard deviation of that group was 50.5. And we are being asked to test this one. Use a 5% significance level, so alpha is 0.05, to test a hypothesis that there's no difference in the vocabulary. So we are basically doing an H not HA story. And they're equal to each other, or they're not equal to each other. So let me show you what I've just written down, and we'll see how that works out. experimental group, control group, sigma, null hypothesis. So pretty similar to what's going on over here. Let's move back in and use salt to do the number crunching then. So if I click on this, I should be able to do a 2 sample, and the sample mean 344.5. Standard deviation was 49.9, and the sample size of this was 30. In the second group, which was the control group, they had a 353.6, a 50.5, and a sample size of about 30. And it's another not equal to 1. Right, I tried this one and it worked. I'm about to try it again, and according to Murphy's Law, it probably won't work, but I'm still going to do it and keep my fingers crossed. We're going to use it to get the t statistic and input, and more important than that, the p-value. And the t statistic is negative 0.702, and the p-value is 0.485. Okay, let's see how that works out. There you go, negative 0.702, it worked fine. Now the p-value was really big. It was 0.4 odds. Do you see why it's there? Isn't 0.485 in that range? Now that's a no. By the way, if you're picking the picture, it's that one. That's a no. And I haven't written them down in my notes, but here they are in front of you. So sometime in the future, you can go and write this down or try and memorize it. That's the sentence that you use when you get no. Is your p-value less than alpha? No. Then that's what you will say. You fail to reject the null, and it's not statistically significant. And what does that interpret as? You fail to reject the null, insufficient evidence to prove whatever it was you were trying to prove. I could take a thumbs up, would be nice. Are we good so far? That's worrying. I'm assuming that you can hear me.
I'm having trouble finding the thumbs up button.
Oh, the thumbs up sign, as long as I got one, right?
Yeah.
Right, hearing it is good enough, Chris, so we're good. Okay, so basically, not quite sure where we are right now. So basically, we've got question 15, and it's essentially the same question again, right? So I'll just leave you to fight your way through that one. But just like the ones we've done, there's your X1, there's your S1, there's your whole story, and you're good. Now that takes me to the last 2 questions. And they are questions 12 and 13. And 12 and 13 has been causing the biggest amount of trouble. I'm just keeping my fingers crossed that everything works out fine this time. We have the information that we need, but it's not being given to us as nicely as the other questions. Do you see that we're not being told X1 bar or S1 or all the numbers that we need to use? All we're being given is the raw data, which is this data here. That means that we have to find all these numbers. But it's not as bad as it seems. If you hit use salt, which is here, it's already pretty much got everything that you need, right? It already knows what the data is called. This is New England and the other place is Rocky Mountain. I think it's to do with crime figures, yeah. If you hit descriptive statistics, there's the mean, there's the standard deviation, there's the other mean, there's the other standard deviation. So when you look at where does the mean come from, there's 3.49. Where did the standard deviation come from? It came from here. That's where all those four numbers came from. So it's like an extra step. You use SALT to find the X1 bars, the S1s, everything that you need to then go on and do the hypothesis test. Now, in this story, we're being asked, does the data indicate that the violent crime in Rocky Mountain, which I better check is X2, is higher than New England, which is X1? Well, a better way of saying that is, isn't New England less than Rocky Mountain? If Rocky is bigger than New England, then New England is less than Rocky. It's the same thing, but said in the other way. There is your guy. There is your statement. The student T is good to go. Now, we are going to figure out what that number is and that number is. So, do we have a p-value? Yeah, we do. Okay. So I'm going to go up here and use SALT. Going to go here, and I'm going to go to inferential statistics. I'm going to do 2 samples, and you can bear with me just for a little while. I'll write down all the numbers that we needed to use. Well, the first place had a mean of 3.49, the standard deviation of 0.8157, and a sample size of 10. And the second one, which was, I believe, New England, they had 3.8667. They had a standard deviation of 0.9316, and there was slightly more people in that one. It's 12. And we were looking for a less than in this story, right? Was the first one less than the second? And then I'm going to generate results. And we'll show you where your number comes from. The T statistic is negative 1.01, and the p-value is that guy, right? So, can you see the T statistic? And the p-value that we're looking for was 0.16213, which is that guy. And you pick one of the pictures, it's this one. And it's a yes. Is that a yes? Let me check. Is our p-value? Oh, it's a no. And because it's a no, you fail to reject, not statistic. You fail to reject, they're not less or more. Are we good with that question? Chris, you're the only one that seems to be able to communicate good, so I'm using you.
Yes.
Are you? Oh, we got 2. Perfect. Right, so you're going to get the same kind of question. They just changed the numbers, but hopefully I've talked you through the process. So there's one last one that I want to do today, which is question 13, and that's us covered what you need to do 8.5, right? So that one went remarkably smoothly, even although it didn't do on Monday. I still don't know what went wrong on Monday. I just think whatever. So question 13, 2 samples. This is Western Western Kansas. And these are 16 communities in Western Kansas, and these are a random sample of people who are over 50. Okay. So you pick a region, and this is 93, and you pick another region, this is 93, and you know, you do what you need to do, 2, 4, 6, 8, 10, 12, 14, 16. Okay, got all the stuff. Right, so I need to get these numbers from this data. So I'll hit use salt. Can anybody remember which one of these headings on the top I'm going to use to get the X1 bar and all that stuff?
Descriptive statistics.
And it's pretty much in front of you now. Can you see there's the means? And then next to it, there's the standard deviations. So if you can imagine these numbers here, these 2 numbers here and these 2 numbers here, that's them. That's where they came from. Right. Now, I'll read on a little bit further. Assume that the hay fever rate in each age group is approximate. Is that hay fever? Interesting. They never told me it was hay fever until we got to here. Okay, so assume that the hay fever rate in each group is approximately normal. Data group of 50 or lower, hay fever, blah, blah. Does the data indicate that the age group over 50 has a lower rate? Well, this is the 50, so if they're lower, isn't that 1 is bigger than 2, right? If 2 is lower than 1, 1 is bigger than 2. Okay. That's why 1 is bigger than 2. So we're going to come up with these guys, and hopefully it's going to match. And I have the numbers. I'll go use salt. Here we go. What one of these guys do you now choose to do the hypothesis test?
Inferential statistics.
Right. And would you agree it's a 2 sample T that you pick? Right. So what do I know? Well, the first group, which is the people from who are under 25, they have a sample mean of 109.5. The standard deviation for that group was 15.37. 371 to be exact. And in that group, there were 16 communities that they looked into. And in the other group, the over 50s, they had a mean of 98.7143. They have a standard deviation that we found was the 11.4383. And the sample size was 14. And we were looking for, if I remember correctly, that the first group, which is this one, is more than the second group. I'll generate results. We have a t-score of that number and a p-value of that number. So let's see if that works out. That is brilliant, it's working. That guy there is your p-value. Sorry, is your t-value. Right, that's your t statistic, 2.197. The p-value is 0.018, which is in that range there, as you can see. Now, is 0.018, is that less than that? 0.018, and the answer is yes, it is. And when you get a yes, it's the reject null hypothesis, statistically significant. Reject the null hypothesis, there's sufficient evidence to prove whatever you were trying to prove. And that went scarily smoothly.